I know more or less what's going on, but not really. So if I get in my car and I drive somewhere and I get there, then the full end-to-end test passed. Okay, we're good, everything's fine. But, oh, thank you. If it fails and I wind up on the side of the road, then it's time to isolate where the problem is. It's time for the mechanic to narrow down, was it the transmission, was it the engine, was it the exhaust system, was it the electrical system, on. And hopefully the design is sufficiently modular so that they can narrow down each part in isolation. Mockito is the tool to help you analyze individual classes in isolation. Each class depends on others. We put in mock objects to say, hey, the rest of those, they're just rigged demos. You know, when I call this, give me this back, and that's it. And that way I can narrow down the problem to a specific area and check the logic in each one. You don't just do a unit test. You also eventually have to put it into practice. You got to do the full-scale integration test at some point. The other global thing I'll say is that if you look at the history of talking about unit tests versus integration tests, unit tests in the beginning didn't mean a single class. It meant a unit of work. It meant a module. It meant a handful of classes together. But very rapidly that message got lost, and now people interpret the word unit test as one class in isolation, and that's not what was intended. So most of the time we do some kind of integration test. We just don't care. I mean, it doesn't, just because it's got a different name doesn't mean it's not valuable for us. Okay, so just global stuff. Now, here is, I have one slide with all my contact information on it. My name is Ken Kousen. It's Kousen like the relative, even though it doesn't look like it. I think it's an Ellis Island job or something, who knows. There's my email address, homepage, blog. I'm still, for the moment, on Twitter, you know, until that goes belly up. I mean, I don't know what did Elon do anything today, you know? At any rate, I'm also on Mastodon, so in case you want to contact me there, that's fine. I have a free weekly newsletter, free, emphasis on the word free, called Tales from the Jar Side, and it's hosted on Substack, and I have a companion YouTube channel also called Tales from the Jar Side. That's where those Mockito videos would be. These are the books I've written in the past, and I was just telling somebody else that I use JUnit for the Kotlin book. You know, I use JUnit and Mockito and tools like that on everything. Incidentally, Mockito comes with Spring. So if you work on a Spring Boot application, they've already got Mockito in the class path and they're ready to go. They have one annotation, Spring specific. Just remind me if you're curious, then I'll bring it up later. Okay. One thing is, again, what I was encountering over and over again in teaching training classes was a lot of people didn't really understand what Mockito was designed to do and how it worked. And I had to fill that in, you know, because the Mockito documentation, let's be diplomatic, it does a good job at explaining the Mockito API. If you want to know what the methods are and what the methods do, the docs are very good for that. What it does not explain is why you want to use it in the first place or where it comes up or anything like that. That's what I felt the need to fill in, and that's what the origin of this Mockito Made Clear book that I published a couple months ago from the Pragmatic Programmers. So the book is here, Mockito Made Clear. There's the GitHub repository. That's the repo I'm going to show you code from. And I keep adding things to it even though they're not covered in the book. There's the link to the YouTube playlist if you want. And I do have a series of articles that come out on Medium because the Pragmatic Programmers have a publication there. So for what it's worth, they have all of those mechanisms, and feel free to keep in touch. You know, contact me if you have any questions. Okay, now I'm going to show you a bigger example. I'm not going to do like a hello world thing because I don't think it's very illuminating in Mockito. So here's what I'm going to do. There is online, let me show it to you, a site called open-notify.org. And they call this Open APIs from Space. And the maintainer takes some NASA data and exposes, for example, the current location of the International Space Station, got a little JavaScript loop updating that, but this is the one I want. Number of people in space. So this is the URL. Notice they're doing their content negotiation. That's too big. By putting .json at the end of the URL. And what you get back is a block of JSON data with message, which should be success, and numbers, the number of people in space, and people is a collection of name craft combinations. Okay, that's what I want. I want to grab that value and I want to turn it into Java classes, and that would be enough, but I want to post-process that, and the output I want is how many astronauts are aboard each aircraft, or each spacecraft. That's what I want. I want to post-process that. So over here, this is the link to that people in space service. And here is the sample JSON data that comes back. Now, I know everybody's calling it JSON, JavaScript Object Notation. I call it JSON because I like picturing a guy in a hockey mask with a machete when I'm working on this stuff, you know? Where's the humor otherwise? There's so much humor that's been lost in our profession. I like to bring it back in. I want the number of astronauts on each spacecraft. So I invoke the RESTful web service. I get back, it only supports GET requests. I convert the data into Java objects, and then I want to do basically a group by operation. If you've done streams with Java, you know about grouping by as a collector. That's all I'm doing. And therefore, I get back a map of strings, which is the name of each spacecraft, and integer is the number of people aboard it. So this is the kind of output I want. Okay. So what I did is I defined an interface called gateway, because the design pattern called a gateway often wraps internet access. That's its job. So I just say get a response, and this thing coming back is going to be my Astro response. I'm going to make a class to represent that. If I was using Java 17, that would be a record. So here's my get response. There's the URL. I can do this in retrofit. I can do this now in Java 11. They have a built-in HTTP client, and I do both in the repository. And so I get that back, get my astronauts in space, and this is eventually going to return that Astro response. So what I want to put in is an Astro service that retrieves the results from the gateway and converts it to that map that I want. So here's the service has a gateway dependency. That's your clue that we might need something like Mockito. I want to test the logic in the service with a given value for the gateway. See, I can use the whole gateway and do a full-scale integration test, and I will. But if there's something wrong, or if I want to simulate something wrong, like the network goes down or something like that, then being able to use mock objects would be very useful. So here I have a constructor to get the gateway into the service, and I have my getAstroData, which returns the response from the gateway, and then I have my group by craft details, which I could show you later. So a full integration test would be to just call this the way it is and check things like the number of astronauts has got to be, you know, not negative, that'd be an error, or that the names of the spacecraft are not empty or not blank. That's an assert J mechanism, by the way. And if everything works, we're good. That's arguably an integration test. And this is an example of that. So I instantiate my service with the real gateway in it. I call the method to get back my map, and I can just check, you know, that assert that the number is greater than 0 or is positive, and assert that the craft name is not blank, you know, all normal JUnit / assert J stuff inside there. But now let's motivate why I might want to use a tool like Mockito. First of all, there's a lot of error possibilities that I can't do myself because I don't control the RESTful web service. See? So what if the network's unavailable? Or what if I coded the networking library incorrectly? You know, HTTP client library is typical Java. It's more complicated than it ought to be, you know? Or what if I'm using a JSON parser and it doesn't work right, or I code it wrong? Or what if I write that logic for the grouping by operation? That grouping by operation is in my service. That's the one I want to test to make sure it's working. Given that the gateway is working, how do I isolate the problem? That's the idea. So I want to test the service and the gateway in isolation. Now I do have a test for the gateway, to make sure that that's working as well. And I think I have that, actually I'll show it later. So the service depends on the gateway, and that's what I want to quote mock or stub. And we'll talk about the difference between those in a minute. We're getting to that. So the gateway that I have in the GitHub repository uses a networking library and a standard parser. And then when I write a test for the gateway, is that a unit test or is that an integration test? See what I mean? This is the sort of problem you get into. It's using some networking library. Now, if it's part of the Java API, is that a unit test? Java still doesn't have a JSON library in it. I mean, I'll use JSON, I'll use Jackson, I'll use Retro. I mean, there's a lot of ones available. If I'm using a library, is that a unit test? We'll come back to that one too, okay? So here is my test of the gateway itself. Just get the response, print them out for each of the people in there, and just assert the things I was telling you before, the number of people is positive, and that the size of the people collection matches the number, something like that. So that's an integration test. It uses a real network. I went out over the network to access it, and the server and the libraries and everything. Is that a unit test? And if it isn't a unit test, should I do a unit test? Let me just answer that now, because it's late in the day. You don't want that much suspense. One of the fundamental principles of Mockito is don't mock classes you don't own. Don't mock classes that you don't have control over. See, there's a couple problems if you do. If you do mock a class you don't own, like mocking the JSON library, for example, then if they version the JSON library, our tests are still going to pass, and we won't know that they're suddenly broken because the library's changed. You know what I mean? Also, say I wanted to mock the HTTP library, the HTTP client library. Well, that requires a mock object for HTTP client, and HTTP request, and HTTP response, and it just mushrooms on, element after element after element. And again, it's like, this isn't even a library I wrote. Why am I doing this? So if I don't own those libraries, a quote integration test is fine. Just go with that. You're good. You only mock things you own. And this is actually in the Mockito wiki, believe it or not. I'll point to that later. So how do we isolate the service, however, from the gateway? The gateway I did write. Well, we could write our own fake object. This is what a lot of people who don't like mocks say. Why don't I just implement it? And we can, in fact, or we could let Mockito generate the fake. Now, here is a mock gateway that I wrote. Probably should have called it fake, but we'll get to the definitions of these terms in a minute. So I made a get response method. I'm implementing the interface. It returns an Astro response, and there's my hard-coded output. If you want a Easter egg, if you will, this is from the book. Will Robinson in Jupiter 2, that's Lost in Space, same actor who played Lanier on Babylon 5. Billy Mooney, if that means anything to you. Whatever, I thought it was funny. So at any rate, I have a hard-coded object here with a method rather to return it. And yeah, I could plug in my own mock gateway and the rest of it's the same test. And that's fine, but in this case I got lucky. There was only one method I had to implement. If there's a dozen methods, you have to implement them all, even if you don't care about them. Also, if you wrote your own mock, you have to maintain it. If the API updates, you got to go ahead and generate it. Also, what if I want to simulate error conditions? I need a second mock. I need another class because I want to actually show that, or I got to put weird if statements with properties in there. If I have this flag, I'll throw an exception or whatever. In other words, it's suddenly become work. Also, I can't check what they call the protocol, the interactions between the class I'm testing and the fake. Were the methods in the mock called the right number of times with the right arguments in the right order? Java doesn't have any built-in way to do that. There's no way to keep track of that. Mockito will do it for you automatically. So no matter whether we write it ourselves or not, here are the steps. You create the mock somehow. You then set the expectations. That means you tell the mock, when I call this method with these arguments, here's the value I want back. And there's ways to generalize that. These things called argument matchers, which we'll get to. Then you have to have a way to plug the mock into the class you're testing. They call that injecting the mock. The most common is to use a constructor, but you could also use setter methods, and Mockito can even do field injection under limited circumstances, okay? Then you run the test, and you make sure it's working. But then you can also optionally verify this protocol, the interactions between the thing I'm testing and its dependencies as they go. So here is an example with the mock. Now, I'm using, in this case, the static mock method from the Mockito class. It takes a capital C class, and it will auto-generate a fake implementation with default values for all the methods, although it's a little smarter than the obvious things. Like if you have a collection, you don't get a null, you get an empty collection. Things like that. It's pretty clever. Then you set the expectations. Now this is the static when method on the Mockito class. When I call get response on the mock gateway, then return that response that I have hard-coded in there. Here I inject the mock into the class I'm testing. Remember, I'm not testing the mock. I'm just telling the mock what to do. I inject it into the service, I invoke the service method I want to know, I write all my checks, and then finally I can verify that on the mock, the get response method was invoked exactly once. See? That verify step is the key to the difference between whether it's a mock or a stub. See, they use the terms interchangeably. People do this all the time. Here's the difference. A stub is a fake object that stands for a dependency that provides specific answers to the method calls. When I call this with these arguments, here's what I want back. You set expectations on a stub, you don't test a stub. A mock does all that stuff and allows you to verify that the methods were called the right number of times with the right arguments in the right order. You verify a mock. If you verify it, it's a mock. If you didn't verify it, it's a stub. But here's the thing, it's the same class either way, right? It's all whether I call verify or not. Now, Martin Fowler wrote a very famous blog post many years ago, about 10, 15 years ago, called Mocks Aren't Stubs. And those are basically his definitions of the difference between a mock and a stub. A mock is about verifying the, quote, protocol, the interaction between the thing I'm testing and its dependencies. Are the methods called the right number of times with the right arguments in the right order? Otherwise, it's a stub. So people say out loud, they just use the terms interchangeably because either way it's the same class. But that's the difference. Okay? Now as long as we're talking about it, what the heck is a spy? But here, there's the summary page with the difference between mocks and stubs, just what I was talking about. The difference is how the created objects are used. So as long as we're talking mocks and stubs, what's a spy? Now a spy has two uses. I said it's a partial mock, but it's not always that. Here's the thing. A spy is a wrapper around an existing class, one that already exists, that's there. Why would I want to spy around it? Well, remember the one thing I say Java won't make it easy to do? How do I know that these methods were called the right number of times with the right arguments in the right order? I mean, how are you going to write that? It requires reflection even then, intercepting all the calls. That's what a spy does. You wrap a spy around an existing object so you can verify the protocol. That my class called the methods in this spied object the right number of times in the right order. Now spies are dangerous because Mockito may make a copy of the existing object rather than use the existing object. Also, if you make it a partial mock, you can set expectations that are inconsistent. Like if I do the one thing that I never want to do, but the Mockito documentation does all over the place, which is to mock a list. They even say, don't mock a list. use a real list, and then they go ahead and mock a list. And what's worse is they test it. And I'm like, this is why I have to write a book kind of thing. At any rate, I could mock the add method so that I verify that I've added elements to a list. But I could also mock the size method to return like 5, no matter how many methods were added or how many elements were added. Now the object's in an inconsistent state. Now that may not matter, but that's the danger with a partial mock, is that you may replace one method that actually affects other parts of the class and you're not even aware of it because the interactions are under the hood. So spies are discouraged unless all you're doing with the spy is checking that the methods were called. That you verify that the methods are called the right number of times with the right arguments in the right order. Partial mocks are a giant red flag, almost guaranteed to come up on a code review. Okay, you know that joke, right? That if you like the other developer, it's paired programming, and if you don't, it's code review? Yeah, anyway. Okay, now here's part of the challenge with Mockito, is there's generally at least 2 and sometimes 4 or 5 different ways to do the same problem. Like, how do you create a mock? Now, first, let me add Mockito to the project. Let me skip this. Oh, actually, let me identify one inconsistency that you kind of have to deal with. There's a class I mentioned called Mockito. It's got a lot of static methods in it, like when. It has a child class, believe it or not, called BDD Mockito. BDD for Behavior-Driven Development. Given, when, and then. What apparently happened is that the Mockito class was created right away when they made the whole framework. And then along came BDD as a discipline. And the Mockito team was like, yeah, this is great. We love that idea. We're going to put in the methods, except they'd already used up the method when. See, BDD is given these objects, when I do this, then here's what comes out. But they'd already used when to start off the process. So they made BDD Mockito, and then they used given and will return. And it's basically a global search and replace on Mockito with a couple of minor changes. So then you're like, well, which one should I be using? And the answer is yes. I mean, the problem is you'll see both in practice. Really, the determining factor seems to be whether the person who wrote the test really likes BDD or not. If they're really into behavior-driven development, you'll see given and will return. Like if you look in the Spring Framework documentation and the Spring Boot docs, let me answer that just in case we run out of time at the end. Spring Boot has an annotation called mock bean. In fact, while I'm talking, I'll bring that up. So if I go to spring.io and Spring Boot and the reference docs and single HTML page, boy, isn't it nice having internet access back from yesterday, you know? And then I want to see at mock bean. I want one more example. That's the one I want. Okay, now, I'm going to try to magnify this, and that always is a problem. So magnify. Yeah, okay, so it was 7 dot, actually, where was it? Actually, you know what? I'll just search on it again. So let me go back one and then down one. Okay, good. This annotation at mock bean solves the injection problem. Remember, one of those steps was to plug the mock object into the class you want to test. Mock bean replaces, not only creates a mock, it puts it in the application context. So if there already was a bean of type, say, user vehicle service in the application context, it'll replace that with the mock so it's available for auto wiring. See, they want to test a user vehicle controller here. That's what this is for. And then they auto wire in the mock MVC API, that's Spring stuff, and they say, you know what, this user vehicle service is a mock bean, so given, now you know they're BDD Mockito, given the user vehicle service.get vehicle details method called with sboot, it will return a vehicle details object. Then they do the test, perform a get with text plain and expect the following, and that's it. So mock bean is the only thing about Spring and Mockito together that you need to know, and you can use Mockito elsewhere just fine. Like the Mockito people will try to inject your mock into the class under test, but they will stress that it's not a dependency injection framework. Spring is a dependency injection framework, so they made this annotation to replace the bean in the application context with your mock. Okay, now we covered that, so let's go on. So again, my recommendation, as sad as it sounds, is get familiar with both of them, because you're going to see both in practice. People who've been using Mockito for years and years probably go when and then. And it's then return, then answer, then throws, you know. But the people who got it later and like BDD approaches will say given and will return, and you need to be able to recognize both. I mean, we read more code than we write, so. Okay, now let's talk about the actual API. The home page is at mockito.org, and it's a little weird the way it's set up. I'm going to wind up saying that a lot with Mockito. I don't want to make it sound like I don't like it. I think they've done a great job with this, but there are issues in learning to use it. Here's the home page, and if you read this, which is really small, you could see that the documentation is on the javadoc.io site. And if you click on that, this is the Java docs for the current version of Mockito, and this is the Mockito class itself, org.mockito.mockito, and they put in a whole series of contents values at the top of this class. And what you'll notice once you play with this a little bit is they're not in any useful order. They're not even remotely a tutorial. They're just like, oh, here's some bullet points to talk about it. And oh yeah, we added this and we added that. See what I mean? This is not a tutorial on how to use Mockito. In fact, let me show you the first example, which is kind of appalling. Let's verify some behavior. Okay, so they say mock on a list, which can, you know, in reality, please don't mock a list. So, but first, let's mock a list. Okay. And then they called add and clear on the mock list. Now there's a problem right off the bat. Who wrote that code? This is not code you write when you mock a list. This is part of the test. You need a class that depends on a list. And when you call a method in that class, it calls add and it calls clear. And then when you come back, you verify it. So you kind of already have to know all that to understand this. But if you don't know all that, then it does tell you exactly how to work with it. Notice the first example didn't even set any expectations. It's just a verify. Whereas down here, oh, let's set some expectations. When we call get of 0 on the mock list, return first. When we call get of 1 on the mock list, then throw a new runtime exception. And then again, here's 3 prints that should never happen in this code. That's in the test, right? Or that's in the class you're testing, part of the method, and then we verify it. Now, in order to make the documentation prettier, I will show you in my GitHub repository, I added a class called adding machine, which takes a list of integer. And I have methods like add elements in list so that I can write a mock for a list and make this work. And I was going to put that in the book, and everybody was like, that's just confusing, everybody. You should never mock a list. I'm like, I know, but you know, anyway. So I'm just letting you know it's there. Now, the Java docs have what little documentation they have. There is a frequently asked question list on the Mockito site at GitHub. So if I go back to, let me do it again. I don't need that one anymore. So here is mockito.org, and I go to GitHub, and there's a wiki link on the GitHub repository. And that's what has this frequently asked question list and how to write good tests and discussions and everything. So that's a decent source of information. Okay? And that's also where it says don't mock classes you don't own, that sort of thing. There is a mailing list I have never seen a lower volume mailing list. You'll get one question every couple of months, which may or may not get answered. I don't know where the team's hanging out, but it's not there. Okay? Here's that note about Mockito versions for anybody who came in after I mentioned that. Mockito 2 really did change the API from Mockito 1. That really is different. But Mockito 3 just established you have to have Java 8. Mockito 4 removed the deprecated classes and methods. Mockito 5 moved up to Java 11, and the core now includes this thing called an inline mock maker. And you're like, what? What the heck's that? I'm not going to define what it is. What I will tell you is if you want to mock methods that are marked final, if you want to mock final classes, you need the inline mock maker. And it used to be a separate dependency in your Gradle or Maven build file. Now it's part of the core. If you want to mock static methods, which again, they don't like, but they'll do it, you used to need this inline mock maker. Now it's in the core, and therefore you don't need to put in any other dependency. That's the only difference between Mockito 4 and Mockito 5. Now the GitHub repository uses Java 11 and Mockito 5 because I'm trying to keep it as up to date as possible. But as I say, there's almost no significant API differences in the last 4 major versions. Again, I don't know what they're doing, but okay. I mean, at least I don't have to relearn it, you know. Now this is what the implementation looks like in Gradle. I put in Mockito core. Now the other thing that we're going to show in a minute, remember how I used the mock method to create my mock? Well, that's old school. Nowadays we use annotations. And there's an annotation called @mock and an annotation called @injectMocks. And we'll see that in a minute. To use those annotations, you need the Mockito JUnit Jupyter extension. See, JUnit Jupyter is JUnit 5, and they don't have run widths anymore. There's no Mockito JUnit runner like there is in JUnit 4. But now on 5, they have an extension, so that's an additional dependency. That's all you have to do. Include the dependency, and then the Mockito extension will instantiate the mocks, will set the expectations, will inject it into the class you're testing, and then you can go from there. Okay, there's the Mockito one. Again, doesn't really, I mean, rather Maven, doesn't really look any different. Okay, yeah, we already talked about complaining about lists and adding machine. I'm going to skip all that now just to say I've got it in the GitHub repository, but I'd rather get back to an interesting one. So, yeah, so the mechanism now, the one that you'll see the most, is an @mock annotation that's placed on each dependency as an attribute. Each attribute in your test class. You annotate that way, and then you annotate inject mocks on the class that you're using. And now, for example, here's the GitHub repository for the book, for the Mockito book, that's the name of the repository. I guess I didn't show you that here. So it's under my last name at GitHub, under Mockito book, because I didn't have a name when I created the repository. Okay? So here is source main Java, source test Java. Let me show you something you haven't seen just to give you an idea. So I have this class called Hello Mockito. Now let me make this bigger. Meant to make that bigger that way. Okay, I'm using a really large font. Is that readable? Okay, so I just made a hello world example. Hello Mockito, what it does is it has a greet method that takes the ID of some person they're going to look up and a source language and a target language. And the idea is when you call greet, you give it the IDs of the person that it's going to find, so it says hello to that person, and I'm going to translate it from whatever the source language is into whatever the desired target language is. The reason I did this is because here's my class and here are my 2 dependencies. I have a person repository which I use to find by ID, find the user. And I have a translation service which has the method to say, well, once I have the string that I want to say hello with, let's translate it from the source language to the target language. So I needed a class with dependencies. Now, here is the test. Let's close that for a moment. And you see how I have the extend with Mockito extension. Now, you can use the mock method. That's fine, and I do in other places. But this is the annotation approach. You use the extension that looks for all the fields annotated with @mock and creates a mock for you. And then you look for the field annotated with inject mocks, and then Mockito tries to be a dependency injection framework. It looks for the biggest constructor and sees if it takes those dependencies as arguments. If it does, and of course I gave it one, then they get plugged in. If there isn't one or that doesn't work, then it looks for setter methods with the right types. And if it finds those, it plugs them in. If those aren't there either, then and only then will it actually try to do field injection. It'll go look at the actual attributes and see if they have the right type and the right name. And that may work, but sometimes it doesn't. And that's when they say in the documentation, look, we're not really a dependency injection framework. If you need one, you know, there's Spring or whatever, see? So I'm going to provide examples that work, and then I'm going to show one example where it doesn't, and I have to work around it, okay? So here is my test. So I say, let's set I see the parts I can now skip are creating the mocks and injecting the mocks into the class under test. So I say, when we call find by ID with any int, I'll come back to that in a minute, that's called an argument matcher. Then return, and I made a new person, which is Admiral Dr. Grace Hopper, with ID and a first and last name and a date of birth, wrap it in an optional because my find by ID returns an optional. When I call translate on the translation service with this string from English to English, then just return the string again. So now I can test the method I wanted to test, which was greet with a 1 and English and English. Now again, I could put in any integer here and then check that it worked. And now I could do the verify, and again, just to save us some time, I also put in the in order part. You see, with the verify, you're testing the protocol. It's not just were the methods called the right number of times with the right arguments, it's also were they invoked in the right order. I have two mocks in this case, the repository one and the translation service one. There's a method in Mockito called in order, another static method, where you could put in a vararg list of mocks. And that way, instead of just calling Mockito.verify, the static method in Mockito, you call inorder.verify after creating this object, and it will check that not only was on the repository, find by ID was called with an int, and verify that the translation service had its translate method called with any string and English, but also checks that they were called in that order too. So it's even the ordering across multiple mocks. And all of that's generated automatically. But you see, here's the payoff for not writing it myself. I can also look for a person that doesn't exist. I mean, what happens if I call find by ID and there isn't one? So I'll say, when I call find by ID, return an empty optional. And the translation service is the same. I call greet, and I see that this time my default is hello world instead of hello with the name. And the rest of that test is the same. Or, now I'm not going to do the mock constructor now. Here, I actually made one of my own. You know what? I'm going to make my own person repository and implement it in memory. And then I had to instantiate it and do all this. And I could do it. But again, if I wanted to test the error, the failure mechanism, I'd have to either modify that class or write a new one. And I didn't want to do that. Okay. Now, before I go any further, that any int is what's called an argument matcher. Now there's a class called argument matchers with an S that has a bunch of static methods like any int, any long, any double, all the primitives, any string, any with a type, believe it or not, any instance of person kind of thing. And then it has string-based methods like starts with or ends with or contains. And then it's got this guy down here, equal. Now this is a weird one. Let me point this out and then we'll get back to other stuff. If I'm going to say when I call translate with any string and English in English, why don't I just say any string in English in English? Why do I have to wrap it in an EQ? Because there's a rule. If one of the arguments is an argument matcher, they all have to be. Not obvious at all. But the error message over the years has gotten really good. So if I was to, like, first of all, let me just show you that this works. And yeah, everything passed, we're good. Now let me take out one of those equals here. And I immediately have an error. Both matcher and non-matcher arguments are used. And if I was able to get it to compile, which I thought I could, but I'm not going to try now, then it would tell you specifically they all have to be matchers. You can't mix. I don't know where that's done because, again, we're talking about methods on mocks here. But that's I mean, at least it's got a simple solution to it. And we go through all that. Okay, anything else on here? I think this is good. Let me also show you I'm going to show you one mechanism that's a totally separate system that motivates the use of mocks again. Here is an interface called publisher. This is an example I borrowed from the Spock framework. In case you've ever used Spock before, they had an example like this, and I thought, oh great, I'm just going to steal it. I'm sorry, reuse? Reusing it, yeah, okay. So, this is a trivial publish-subscribe mechanism. I have a publisher. It has a list of subscribers. Subscriber is an interface that only has the method onNext. If you've ever done reactive streams, this will look familiar. You know, you have a publisher sending off signals, and the subscriber receives the signals onNext, onNext, onNext. All my types here are strings, though, to keep it really simple. Here's the one method I want to test, send. I'm going to send a message to all the subscribers. So for each subscriber, I'm going to call its onNext method. If any of the subscribers throws an exception, I'm going to catch it and ignore it, which is evil, but there it is. How am I going to test this method? See, the problem is, there's a couple problems. First of all, it returns void. And any method that returns void is hard to test anyway. Usually the way you test methods that return void is to see how the method changed the state of the object. It changed its attributes. That one doesn't change the state of the object. I just have a list of subscribers before and after. So that's not going to work. So what am I going to do? Well, this is where Mockito pays off. What I'm going to do is check that on each of the subscribers, their onNext method was invoked with the proper argument exactly once. Okay? I need the mock for this. Now, before I go over there, notice there's no constructor in publisher that takes a subscriber or even a group of subscribers. I have a subscribe method, again, more like reactive streams, that takes a subscriber and adds it to the collection. Now, if I look at the test says, let's instantiate a publisher. That's the class I'm testing. I'll use the mock method. Again, this works really well with the mock method rather than the annotations this time, so I can make 2 subscribers. See, that would be hard to do with fields. I'd have to give them different names. I mean, it can be done, but still, this is easy. I'll just make 2. And in my before each, I will inject them into the class I'm testing. Now I say when I call send on the publisher with the string hello, I verify that on each subscriber its onNext method was invoked with the string hello, and now I believe that my infrastructure worked. It did what it was supposed to do. And I tested a method that returns void. Now I can't think of anything else I can do with that. I think it's about as much as I can do. I can even test, however, for what they call misbehaving subscribers. Now, there's a subtlety to the actual API. You notice I'm not dwelling on the API that much, because you can learn the API just from reading the, frankly, from your code assist. I want you to understand how to use it or why. I would like to write this line. Let me uncomment it. When I call onNext on sub1 with any string, then throw a runtime exception. I can't do that. And the reason I can't do that, it says a terrible message. It says reason, no instances of type variable t exist so that void conforms to t. And I'm like, what? Here's the problem. OnNext, the method in the subscriber, also returns void. You can't chain a when call on a method that returns void to a then anything. And again, you just have to know that. You get that from the documentation, because that error message doesn't help me. But the workaround is trivial. You say do throw or do return or do answer with what you want when we call onNext with any string on sub1. So you just write it in a different order. And all you have to remember is if the method you're mocking returns void, you use the do methods. That's all you got to know. And be honest, you can use the do methods anywhere else too, but people don't. They go with the standard when and then return, probably just for historical reasons. Okay? But if the method you're mocking returns void, you need the other syntax. So at any rate, those work too. And remember, I caught and ignored the exception. So I could say, hey, on sub1, here's one of those argument matchers. Matches returns a string, takes a regular expression. So instead of just saying it matches on any string, which is fine, I just thought I'd illustrate my messages here have a pattern, message space, and then a digit. So I'll say message \\d, my regular expression. So I can be a little bit more specific. Here I could check that they're in order, but now I've done something dangerous. When you wind up with projects that have thousands of tests, a danger is you may overspecify the tests and make it so that you can no longer modify the project. Mark Richards, in an earlier talk a couple hours ago, was talking about a case where he went into a project, tried to change an error message, wound up breaking like 200 some tests. That's overspecified. There's no reason to get into that level of detail in your tests. You've now restricted what the implementers can do. Well, here's an example of that. I said, you know what? I could verify that onNext was called in order, first on sub1, then on sub2. But, what if I went back to my publisher and said, you know what? Let's use parallel streams. I don't care which onNext is called. I just want to notify all the subscribers. Why do I care what ordering? And now my test is broken. And it's like, that wasn't the fault of the implementer, that was the fault of the test. They overspecified the implementation. See, this would fail because the order of the calls is not guaranteed, for example. Okay, so there's that one. One last thing about this one before I go back to the Astro one. There are a lot of cases I've noticed in APIs where the implementers got lucky when lambdas came along. When you use lambda expressions in Java, they are associated with functional interfaces, an interface with a single abstract method. So if you wind up with an API that has interfaces that have only a single abstract method in them, you can implement it with a lambda, and this is a case where the Mockito people got lucky. See, in this API, actually, I'm not going to dig into the API, I'll just tell you. There was methods in that argument matchers, like any int and any float. There's also a method called argThat. ArgThat takes an implementation of the matcher interface. There's argument matchers as a class. argThat takes an argument matcher singular. Argument matcher is an interface with a single abstract method. Okay? So if you look in the documentation for argument matcher, they show people implementing it with an anonymous inner class, which nobody's going to want to do. But here I'm implementing it with a lambda. So here I'm saying verify that the onNext method was called with an argument that, with an arg that satisfied this lambda. The string matches this pattern. Now again, I could have done the matches method, but I'm trying to show an implementation of an argument matcher, and it was invoked twice, 2 times here, like that. That's a custom argument matcher, and it's easy to do once you realize you could just use a lambda. Whatever the argument is, just write your condition that returns true, a Boolean. It's got to return a Boolean, that's all it is. So that's an example right there. Now, let me go back to the Astro example. So here is my, let me just go to the test. This is my Astro client, Astro gateway using the HTTP client. I also have one that uses retrofit. The implementations are different. The tests are basically the same. I just want to test both implementations. And I'm just checking that I get back records here. Actually, I don't think I use records anymore. I didn't want to require people to use Java 17. So in fact, this is a POJO. It was a record, but I made it a POJO. Okay, just so you can use Java 11 on this without a problem. And that's fine. Here's the Astro service test. So there's my hard-coded response. There, oh, sorry, top is extend with Mockito extension. Then I mock the gateway, I inject it into the service, and here I'm using the injected gateway. I just call get response. I call the method I want to test. I verify, and this, by the way, is some cool methods from assert_j. Assert that the map contains the following 3 entries. That's a neat little mechanism, isn't it? That's from assert_j, though. It has nothing to do with Mockito. And then verify that get response was called on the gateway once. See, there's a second argument that's optional in the regular Mockito class, which is called times. And times 1, IntelliJ would go, you know you don't need that, right? And would ask you to eliminate it. Here's the same thing with the BDD approach, by the way. Given get response on the gateway, return that response, will return the response. Same thing here. Notice this time, they don't have an optional second argument on the then method. They have a should method, which takes the number of times inside it, defaults to 1. So that's the only thing that keeps it from being a global search and replace on the other one. Okay, but that's the BDD approach. But I can also check a failed gateway. When I call get response on the gateway, throw a runtime exception wrapping an IO exception, network problems. So now this is assert_j. Assert that exception of type runtime exception is thrown by the method I'm testing with cause instance of IO exception with message containing. I'm like, oh my goodness, that's assert_j is cool. But it's huge. You'll be spending weeks learning, you know, oh, I didn't know I could do that, you know. And then, of course, I verify it. This is the same thing with the BDD approach. Same basic idea. This is the integration test with the retrofit one. Again, that's fine. This is the HTTP client. This is the one where I wrote it myself. And I think that's it. Yeah, so just for the record, no pun intended. Let me run it. And they all pass. So everything in the repository it better pass, you know. So that's all in there. All right, couple last things and we'll be finishing it up. Okay, that's the BDD then and should compared to the verify in the regular Mockito class. If you're still on JUnit 4, life gets complicated again. There is a Mockito JUnit runner. So that's fine, you could do that. But alternatively, let me skip that. Yeah. There's 3 ways to set up JUnit 4. One is with the JUnit runner that I just mentioned. Another one is to call open mocks from Mockito annotations inside your before method. You know, right ahead of time, make sure each one runs. And the third way is they have a JUnit rule. JUnit 5 is easier, but you could do any of those and they'll all work. There's another difference, by the way, between the JUnit 4 one and the JUnit 5 one. In JUnit 4 with Mockito, the expectations are lenient, whereas in JUnit 5 they are strict. What I mean is, if I try to mock find by ID everywhere in Mockito JUnit 5, I'll get errors in any test that says you never called that method. That's what strict means. If you mocked it, you better call it. If you set expectations on it, it has to be called. Whereas lenient means you could call it or not, I don't care. It's not hard to change the behavior, you just set a flag. You know, it's very simple to go, yeah, I'm setting the expectations to be lenient this time. But it's trying to encourage better practices, if you will. Inject mocks, I mentioned the mechanism for that. This was injecting the mocks, yeah, we talked about it already. The configuring them, if you look for the methods, you know, you get default values and empty collections for collections. The rest are kind of obvious. Let's move on. I talked about the argument matchers with the anyint and all the any's, and then here's anyint. You could do that both in the expectations and in the verify step, both, or mix and match. And here's a list of all the argument matcher mechanisms in there. There's the equal one I was telling you about, where you have to, if you use one argument matcher, you have to use them all. Here's the custom one with the argument matcher, which has, this is the single abstract method. So I don't really care about the name, but it takes the thing you're mocking and return a Boolean. Like here, the example was they're mocking a list again, but they're going to say only lists of size 2. See how that's a custom matcher for lists of size 2. Anything else here? Yeah, oh, that's the one last weird quirk I need to warn you about, because it's not obvious again. If you try to do arg that with something that involves primitives, you could wind up with this really weird error message. Null pointer exception auto unboxing caveat. And I'm still not sure what the heck they're talking about. Here's how you fix it. Instead of saying arg that, you say int that or long that or double that, whatever the primitive is. They have an overload for that. And that fixes the problem. So that's all you got to remember. The verifying we talked about, there's the multiplicities that are available. And methods that return void use the do methods. And in order, and spies I already told you about, there's a spy method and a @spy annotation, either way. We're not going to do argument captors. And if you want to mock final types or final classes or even static methods as well, then this was the extra dependency we had to add before. Now it's part of the core. You don't have to do anything special. I have examples in the repository of mocking both static methods and final methods. You still can't mock strings. That's not allowed, or any of the wrapper classes, integer, double, etc. Can't mock those. But I was able to mock local date, even though, again, you're not supposed to mock what you don't own. Again, there's the recommendation and the link, and yeah, all those restrictions have been taken away, although they refuse to allow you to mock private methods or equals and hash code. And that's everything. That's basically it. So thank you very much.